4.4 continued. I've started it.
You said what?
4.4 continued. Alright, 4.4 continued. So, the first thing we need to talk about is the absolute value equation. If I can get, the dot cam's been unhappy all day. This is the new one. This is the one they bought us.
Like a 1955 Elma.
Here we go. So, absolute value recall that absolute value is defined as x when x is greater than or equal to 0, and the opposite of x when x is less than 0. So we talked about this last semester, and I pounded it into your head when we talked about limits. Okay? So, now let's do an example so that we can do number 10 on the homework. So we're just going to evaluate. So, we're going to evaluate the integral from 0 to 2 of the absolute value of 2x minus 1 dx. So your first step when doing this is to find boundary points. So when you find your boundary, you just set what's inside the absolute value equal to 0. So your boundary is just x equals half. And then your second step is to build your piecewise function for the absolute value. Now it's really easy if you actually understand what the piecewise function is over here, because it follows the same format, okay? It's the absolute value of 2x minus 1 is defined as the same thing when x is greater than or equal to half. So I just replaced the 0 with the boundary point. Okay? Then I make the second part opposite, but I have to make both opposite, yes. Negative 2x plus 1. When x is less than half. So what that does is that's going to split my integral into two different parts. Okay? So what I'm going to do is I'm going to start at A. Okay? This is step 3 is to like rebuild my integral here. So I'm going to start at A and go to my boundary. So A is 0 and go to my boundary half. And 0 to half is all numbers less than half. So if it's numbers less than half, I'm going to replace this with this. Because this is what I need to use to evaluate, because I always need absolute value to be positive. Then plus the integral from half to 2, so I finish the rest of the integral. And from half to 2 is positive, and so then I just get 2x minus 1 dx. Any questions on that? Or does that like intuitively make some sense? Okay. So then we just integrate. Okay, so that's step 4. And I just integrate them separately, evaluate them separately, and then I add together. Okay? So this is going to be negative x squared plus x evaluated from 0 to half plus x squared minus x evaluated from half to 2. Did you lose me on the integral? It's a little funky because there's 2 of them, but that's also why I said yesterday sometimes these lines actually save you, because otherwise you don't know what you're evaluating. Okay? Alright, so here we go. Now we have to do f of b minus f of a on both of these. So we're going to have like 4 parts. Okay? So here we go. So negative half squared plus half. So that's f of b. Then minus f of a is just going to be 0. So I told you if it's 0, you can just write 0. You don't have to like show that you plugged it in. Okay? So that's that first part. Now, I'm going to put a plus here because the plus comes from the absolute value function. That has nothing to do with the f of b minus f of a. That came from what I was doing here. Okay? So then, I've got negative 2 squared. Whoa. No, that's just positive 2, right? My bad. I'm not plugging that in here. I'm plugging it into there. Yeah. So 2 squared minus 2 minus half squared minus half. Okay, so this is negative 1/4 plus half. I don't need the minus 0. Plus 2 squared is 4. 4 minus 2 is 2. Minus 1/4 minus half. So then that's negative 1/4 plus 2/4 plus 8/4 minus 1/4 minus 2/4. So that gives me 1/4 plus 8/4. Now this is going to be minus negative 1/4. So that's going to be 1/4 plus 8/4 plus 1/4, which is 10/4, which is 5/2. You can use extra paper on number 10. So that helps you with number 10 on the homework, okay? Yeah, I think I accidentally cut off the rest of the page, so if you have to do that somewhere else, you can. Because he's right, it is a tiny box to do it on. Alright. Cool. So, now we gotta learn some conceptual things. We did one problem. Okay, here we go. The mean value theorem for integrals. So the mean value theorem for integrals says that if f of x is continuous, on the closed interval a to b, then there exists a c such that the integral from a to b of f of x dx equals f of c times b minus a. So that doesn't say very much because this is the main theorem, okay? But there's a consequence of this theorem called the average value theorem. And the average value theorem is actually used to find the mean value theorem. So I give them to you one way, but then we use them the other way. Yes. So, average value of a function says that if f of x is integrable on a to b, then the average value of the function on that interval is 1 over b minus a times the integral from a to b of f of x dx. So on the example we're going to do, we're actually going to find the average value first, then find the c that exists for the mean value theorem. So it's really not anything different than we've done before. And if you remember mean value for derivatives, it's that exact thing where we set it equal to c and we factor and we solve. That's what we're going to do. Okay? Any questions on this part? An example will help. It's really not, it looks a lot worse than it actually is. Okay, here we go. The problem's not that bad. We're going to integrate and then we're going to factor.
Is it long though?
You should be fine. You could probably do two sides. Like, split it in half. You might be okay. Alright, so here we go.
Just throw it on the back.
So this is example 2. Our last example. So A, find the average value of f of x equals 3x squared minus 2x on the interval from 1 to 4. Okay? So if it says average value, the only thing you have to add to your function is 1 over b minus a. So that's what we're going to do. We're going to do 1 over b minus a, the integral from a to b of f of x dx. So we've got the integral from 1 to 4 of 3x squared minus 2x dx, and then we're going to multiply that by 1 over b minus a, so 1 over 4 minus 1 So that's going to be 1/3 times the integral from 1 to 4 of 3x squared minus 2x dx. I meant to put this up there. That's why it moved. So 1 over 4 minus 1 is 1/3, right? Okay, so here we go. Let's just integrate this. So 1/3 times x cubed minus x squared, evaluated from 1 to 4. So remember, to integrate, it's 3x cubed over 3 minus 2x squared over 2. And so that simplifies to that, right?
Should we distribute the 1/3?
Bless you. You can either distribute the 1/3 now. I actually did it later, but I didn't think about doing that now. Let's distribute it. That'd be fine. I didn't do that earlier. Yeah, you can distribute the 1/3. So x cubed over 3 minus x squared over 3, evaluated from 1 to 4. Okay, so here we go. Yeah. There is no plus c. Remember yesterday plus c went away because we have limits now. Yep. Alright, here we go. 4 cubed over 3 minus 4 squared over 3 minus 1 cubed over 3 minus 1 over 3. (64 over 3 minus 16 over 3 minus 0. (48 over 3 gives me 16. So the average value for this function is 16. So then, again, we have to use the average value to find the mean value. And so how they word the mean value is find the values of C guaranteed by the mean value theorem for integrals on the interval. And that's a big deal. It has to be in the interval. Okay? So, how you do this is, since the mean value theorem says it's the integral from a to b of f of x dx equals f of c times b minus a, and I told you the average value is a consequence, right? That means I can switch this around to make it look like the average value. If I divide by b minus a, I can make this 1 over b minus a integral from a to b f of x dx equals f of c. This side is exactly the average value. I already found the average value. What's the average value? 16. What's up? If I divide both sides by b minus a, right? Alright, so that means 16 equals f of c. 16 equals f of c. So I have to go back to my f of x. Go back to my f of x. And I'm going to set 16 equal to my f of c. So, 16 equals 3c squared minus 2c. That's a quadratic. I need to factor that quadratic, but I gotta set it equal to 0 first. So 3c squared minus 2c minus 16 equals 0. Two numbers that multiply to give me negative 48 and add to give me negative 2 is going to be negative 8 and 6. So c minus 8 times c plus 6 equals 0. I borrowed a 3. I have to pay back a 3. Bottoms up. 3c minus 8, c plus 2 equals 0. Set both parts equal to 0. C equals 8/3 and C equals negative 2. But the big deal about this is that this has to be in the interval, and one of these numbers is not in the interval. Which one's not in the interval? Negative 2. So this C does not work. We just cross it out. And so our only answer is C equals 8/3. You do the same thing every time. So the only difference from this and a derivative is we take the integral and then set it equal to the function and factor and solve.